So we're going to talk a little bit about parallel and series circuits in terms of resistance. I have two pretty identical straws, and if my life were depending on it, I could probably breathe through one of these straws. I don't think I'd want to do that forever, but I could get away with it. Now, there are smaller straws than this that, of course, would make that a lot more difficult. And the analogy would be that I'd have a lot more resistance to the flow of air, a lot more resistance electrically to a current. Now, if I have two resistors and they're parallel to each other, I'm a lot happier. How much happier? Well, we could probably quantify that, couldn't we? But I literally have two extra areas, much less resistance to airflow. So it's the same thing electrically. Now, I could take it and I could compare the resistance for something that has less restriction. Now, I'm much happier now, right? Because I have much less resistance here. So it's not saying that the size of the resistor is what's important. What I'm saying is the amount of resistance to the flow of current is the same idea as the amount of resistance to the flow of air. If I have more resistance, that means I'm actually going to have less airflow, everything being equal. So, interestingly enough, I could also breathe with the large and the small openings in parallel, or try this one on for size. I'm a lot less happy with them in series than I am with them in parallel. Isn't that true? And it doesn't really matter as far as my analogy is concerned, which one is in front of the other. So again, think about it. Resistance to airflow is a lot like resistance to electron flow. And you'd much rather breathe in parallel than in series.